So a while back, I posted a schematic of a power supply that I designed. Here's a schematic. Well, I've been working on it for about a month now, and I'm finally finished. Unbelievable amount of work went into this thing. Of course, it's got a lot of bells and whistles. I can't be happy with just something simple. I know the schematic's hard to see in camera, so I drew up a couple of the parts of this, and I want to explain it a little bit before I show you the finished product. So I have this whiteboard here, and this will explain a little bit better what's exactly in this power supply. I have three different things going on inside the supply, and I have them listed right here, 1, 2, and 3. The first thing I have is a variac, which is essentially a way to vary the voltage. And when I say voltage, we're talking about AC voltage, the voltage that comes in on your house and on your sockets, things you plug your appliances into. This power supply is used for testing things that you would normally plug into the wall, and you get 120 volts AC. So this variac, its main purpose is to vary that voltage, so you get 120 volts AC in, and you could vary that voltage anywhere from 0 up to 120. The variac I have actually goes to 140, so it would be from 0 to 140, and you'll get that out on your reset. So that's the first thing that's in this power supply. The second thing I have is, which every tech bench should have, especially if you're building amplifiers, tube amplifiers, and if you have or acquire old equipment that's possibly been sitting around for 20 years and you're not sure if it's working or if there's any components going bad. You don't want to just plug it into the wall. If something's bad, well, you risk damaging it more. So that's where this number 2 comes in, with the dim bulb tester is what they call it. And essentially what you're doing with this is you're putting a light bulb in series with the hot line. So what that does is, if there is a short in whatever you have plugged in here, your tube amp that you just built, or your test equipment that you just got that's been setting for God knows how long, and you're not sure if it's good or not, there's a light bulb in series with that. So if there's a short in here, this bulb is going to light up really bright. And it's going to do a couple things. Well, first of all, it's going to tell you that there's a short in there and there's something wrong, so you'll just immediately shut the power off. But the other thing that it does is it limits a surge to this device, and hopefully it limits it enough to where it protects the valuable components inside without doing any damage to them. It also limit the current, because if there's a short circuit, essentially this isn't here, and you've got a light bulb in circuit, and that's it. So you're limiting the current to whatever the wattage is on these bulbs. So you could change the wattage on the bulbs and get different current limiting action. And also, this is a switch underneath here, and that's just to short the bulb out of the circuit. So once you're done with your dim bulb test and you feel confident that everything's okay, then you just close this switch, and then you got a regular 120 volt circuit with no light bulb in the hot leg anymore. So essentially you just got a regular outlet. That's number 2. Number 3 is an isolation transformer. This is something else every tech bench should have. And what this does is exactly what its name is, isolation. So it isolates the incoming power, incoming voltage from the outcoming or the output. So anybody who knows anything about transformers knows that there's no connection here between these two. These are coils of wire, and by adjusting how many turns are in each side, you could increase, step up, or decrease, step down the voltage. That's what those big cans you see out on the utility poles. That's transformers. They're boosting the voltage or decreasing the voltage, whatever needs to be done to get the voltage proper to go into your house. Well, this is essentially a one-to-one transformer, so the windings on this side and the windings on this side are the same. So you have 120 volts in and 120 volts out. Well, what good is that? Like I said, it isolates. There's a level of protection there. There's no physical connection here. This is all done by magnetic induction through these coils, the transformer action. So that does a couple things. That protects me, the tech, that's working on the equipment, and it also protects the equipment that's plugged in here. So it's a safety thing. So this power supply I built incorporates all three of these things, and of course there's all kinds of bells and whistles. So I'm just going to go ahead and show it to you right now, and we'll take a look at it. Let me get the cameras turned around here and set up. Okay. Alright, so here it is. There's two parts to this. There's this part up here, and there's this part down here. This is the variac here. This is how I vary the voltage, the adjustable voltage from 0 to 140. Okay. And I got a fuse. It's protected with a fuse. This is the main power switch. This turns everything off and on. And then I got two outlets here. I got 0 to 140 and I got 0 to 280. That isolation transformer I have also has another set of windings where I step up the voltage, like I was explaining. So I have, there's actually 4 sets of windings on there. So I got a 1-to-1 winding for my 0 to 140. And then I got a 1-to-2 winding from a 0 to 280. So I have 140 volts AC available in this socket, in this outlet. And I have 0 to 280 volts AC in this outlet right here available. And this is where you plug in your, whatever you're testing, your guitar amp or your test equipment or whatever it may be, power supply, and you plug that in there, turn your power on, and up here is where these are the bulbs for the dim bulb tester. I've got 2 bulbs, and I've got a way to use either just the lamp A or lamp A and B. So just in this unit alone, without changing any bulbs out, I got a little bit of variety there and some options by hitting this switch right here. Let's see what else. I got 2 meters here. These are digital meters. I decided to go digital because I'm getting a little older and my eyesight's going, so it's a lot easier to see a digital meter than an analog meter. Alright, and this thing took a crazy amount of work. You see everything here is square, and drill bits don't drill square holes, so just square switches, square meters, that's a lot of work. Up in this box I have everything. I have my transformer for my DC circuit. So the AC's coming in here, it's getting rectified, turned to DC, and the DC is powering a little circuit board that I built. I believe I posted a picture of that also. And what the only purpose of that is to power these meters. So I have DC, 12 volts DC powering these 2 meters, and I have a strip underneath here so I could add more meters. I'm going to add 2 more meters here in the future, one here and one here. They're right here, digital, 2 more digital meters. So I'm not done with the bells and whistles. There's going to be a couple more things, but I had to get this thing up and running. I had to see some progress. In the back here behind the bulbs, there's 3 relays, and that does all the switching. So that's part of the bells and whistles that I was talking about. And this switch in particular, I completely tore this switch apart, and I put LEDs inside of it, which you'll see in a moment here. I put a green and a red. A red meaning the current limiting is off, and the green meaning that the current limiting is on. This power button powers up the meters. This switch switches lamp A in circuit or lamp A and B in circuit, and then I got these 2 LED indicators just so you could visually see exactly what's going on. So let's go ahead and turn it on. Just hit my main power switch down here. And so the main power is on. You don't see anything happening up here except for this light's up. I don't know if you can see that in camera or not, but there's a red light inside this switch telling me that the current limiting is off. So when the current limiting is off, that means that the straight through, these bulbs are not in circuit. The dim bulb tester is not being applied to this outlet, to either of these outlets. So let's go ahead and turn the meters on. And this meter is my 1 to 40 down here, and this meter is my 0 to 280 right here. So by turning this variac, I could get different voltages. So we'll go right there is right around 40 volts or 80 volts. And let's go up to here. That's about midway. So it should have 70 volts or 140 volts. Very close too. I'm going to go ahead and set it for 120. That's the regular voltage coming in. So you can see it's 120 volts AC. Now, like I said, by hitting this switch, I could tell if it's current limiting or not. Now it turned green. I have the switches pushed in. The bulbs are now in circuit, so now anything that I plug in here will be protected by this dim bulb tester. Okay, and like I said, I could have just lamp A, or I could have both lamp A and B. These are 60 watt bulbs, so together there's 120 watts there, which limits the power to about 1 amp at 120 volts. So let's go ahead and test this thing out. So down here I got a switch, and I got this cord plugged in to a switch. So essentially this switch is acting like my device under test or whatever. I just brought home a guitar amplifier that I bought, and it's been sitting down in dude's basement for 40 years. Now I don't know if it works or not, but I'm going to plug it in and see. Now I got my current limiting on, which I want, because that's going to protect it if something is shorted. So this switch is going to act like that device, that amp, and when I plug it in and I hit this switch, I'm essentially turning that amp on. Now, so what happens when I turn this switch on? Bam, the light bulbs come on. Right away, you see my voltage went down. That tells me right away that there's a short in that circuit. Alright, so I need to turn that power back off right away. You can see it also takes down the voltage. Remember, it was at 120, now it's at 96. So it's protecting it in several different ways. Once I feel confident that there is no shorts and I want to do further testing on it, then I'll go ahead and take the current limiting off, which gives me my full voltage, and I could continue with all my normal tests. So this is my power supply. I'm completely psyched about it. It's pretty badass. It's got a lot of bells and whistles. Took a lot of time to do. I designed it, drew the schematic, and wired it up. Everything went great. Worked on the first try. So that just goes to show you what good planning and taking your time and not hurrying and rushing things could get you, you know, a successful build. So I hope you all enjoy it. I know I do. I have to show someone, so it's everybody out there on Facebook. That's, you guys get to see it. So, all right, thanks for looking. Till next time.